So upon the completion of this lecture session or section, you will be able to understand basics of microcontrollers and microprocessors and different microcontroller families and ARM and ST families. So I'm not sure we will cover the point 2 and 3, but at least we will cover the first point. So basics of microcontrollers and microprocessors. So you should know first the difference between microprocessors and microcontrollers. You may heard about microprocessors somewhere, and you may heard about microcontrollers also somewhere in your earlier days. So have you ever thought about the differences between them? So here you can see microprocessor. Microprocessor means this is just a CPU on a single chip. So for example, in your PC, in your laptop or a desktop PC or whatever, you have a motherboard. So motherboard is carrying everything. That is the PCB, printed circuit board. It has all the chips and active components and passive components. So among the active components, the microprocessor is the heart or the brain of the entire motherboard. So it's processing all the data. So what the microprocessor is having, it has the ALU. This is the arithmetic and the logic unit. It performs all the arithmetic and logic operations. Arithmetic means what? Addition, subtraction, multiplication, division. These are the arithmetic operations. And logic means mostly logic is indicating the comparison. So maybe in your digital electronics course, you have studied about digital elements, particularly gates, AND gate, OR gate, XOR gate, AND gate, OR gate, NOT gate, and NAND gate, NOR gate, XOR, XNOR. So these are the basic digital components or digital elements we are using inside this microprocessor. So first of all, how can we design one microprocessor? That is another big long story. So you have to use a separate language. It's called HDL. So it means hardware description language. So there are two hardware description languages, that is Verilog and VHDL. So anyway, this is not part of this course. So you have to write the function of the microprocessor by using these languages. For example, we can use Verilog. And then you have to do the synthesis of this coding by using some specific technology library. And then you have to do some pre-simulations and post-simulations, and you have to check the timings and clocks, everything is working. If everything is okay, then you are sending this final file to the factory, that is the fabrication house. They fabricate in terms of chips. So that is the microprocessor. So microprocessor contains the ALU and then registers. Registers are used to store the data temporarily during the process of the data. And control is important in any system. So these are the modules or blocks is included in the microprocessor. So none of the peripherals, no peripheral is included in this microprocessor unit. So if you, okay, we can just see the picture, then you will understand. So this is the microprocessor. So the microprocessor, this is all the microprocessor. It has the ALU and register array and then control unit. And then the IO unit. So this is the input output unit. For example, in your PC, you have the input output. What is the input? The keyboard is the input and then output is the monitor you are seeing. So this is the input output unit. It doesn't need to be only the monitor and keyboard. It can be any other input or output unit. So it maybe the input unit can be the switch. You can use some switch. The output unit can be, for example, some kind of buzzer or whatever. So this is just one example. So all these input output units or IO peripherals are outside of this block. And we have the system bus. Bus means that is just helping to transfer the data between different modules. And we have external memories, that is ROM and RAM, so read-only memory and random access memories. You should know the difference between ROM and RAM. Okay, so everything is external. So here we have general purpose microprocessor and the RAM, ROM, IO port, timers, serial port, ADC, DAC, everything is outside of this processor. That is microprocessor. So all the units and the microprocessor are connected by buses. It can be a system bus or data bus or address bus or whatever the buses. There are different types of buses. So this is the microprocessor. So that's why we call microprocessor as a CPU on a single chip. So then the other way, the microcomputer or microcontroller is something different, little bit different. So what is happening in the microcomputer? Actually, microcontroller, it's called microcomputer. Why? Because it has the microprocessor, yes, and then it has IO ports, that is input output ports, that is also on board, and it has the internal inbuilt memory, and it has inbuilt peripherals. So everything is inside the single chip. Here we have only this one is inside the single chip, and then all others are outside, external. Here everything is inside the single chip. That is the beauty of the microcontroller. So all in one chip. That is why we call the microcomputer or microcontroller as a microcomputer. So the entire microcomputer is on a single chip. Okay, so this is the difference between microprocessor and microcontroller. So here, as I said, like this is the microprocessor. So we have this processor unit, and then everything else is external and connected by buses. But the microcontroller means, so here we have the processor, we have the memories, and then IO port and timers and serial ports and so on, and everything is connected by buses, same like the microprocessor, but everything is fabricated within a single chip, right? So that is the biggest difference.